In this video, I'm going to be focusing on the various operators that C++ provides. This is going to be a brief introduction to the most commonly used operators. So let's start with the arithmetic operators. Most of you would be familiar with the addition, subtraction, division, and multiplication operators, and of course the modulo operator. Uh, Less frequently used are the unary plus. Unary minus is used as well. Now let's see a couple of these in action. So I've defined two variables here, a and b. And I'm trying to get the value of a mod b. So usually if the operand to the right hand side of the modular sign is negative, that negative sign is disregarded. So you would actually get the same result as you would have got if you had done 34 mod 7. So let's run this and see what the result is like. So as you can see, we have got 34 mod minus 7 to be the value 6, and that's what we expect. All right, so let's also now quickly see what we get if we did minus 34 by 7. So it's minus 34 mod 7. Now this is going to be a negative value because the negative sign of the left hand operand is always taken into consideration. So let's run that and see what we get. I've got minus 6 as the result. Awesome. So let's continue. So I'm trying to use the unary minus. So I have defined a variable c to be 39, and I'm using the unary minus symbol here on c. So 39 is going to become minus 39. So let's quickly set a breakpoint there as well and see what result we get. All right, so as you can see, negative c is minus 39, and that's the result that we expect. All right, let's move on now to logical and relational operators. The logical operators that are most commonly used are the AND operator, the OR, and the NOT operator. So the relational operators, of course, are the less than or equal to, greater than or equal to, the not equal to operator, and the equal to operator. So the logical operators and the relational operators, when you apply these operators, and you have operands as well, on either side of these operators, the results are always going to be booleans. So let's see these operators in action. So I'm going to have a set of statements here, which is going to like take a look at my salary and my savings. So very simple logic here. I'm just checking to see what my salary value is. So if it's greater than 5,000, so I mean, if this evaluates to true, and if my savings greater than 100,000, if that also evaluates to true, then I'm going to say that I'm rich. But if it's say at a different uh, level, right? So if it's only greater than 3,000 and it is less than or equal to 5,000. So if this evaluates to true, or if this statement evaluates to true, my savings is greater than just 50,000, then I'm moderately rich. And if both these conditions do not get satisfied, then yeah, I'm obviously really poor and I better start working. So this is, a very simple example of how we will use logical and relational operators. So let's see that as well in action. So for now, I've taken the liberty of declaring my salary to be 3,400 and my savings is a paltry 1,000. All right, let's run that and see what's the output we get. So as you can see, I am moderately rich, which is not too bad. So that's because this second condition gets satisfied. So it's 3,400 is greater than 3,000 and my salary is less than or equal to 5,000. So 3,400 falls within this range. So one thing that you need to bear in mind is that we got an logical OR operator here, and if the first part, the first operand evaluates, the first expression evaluates to true, the compiler normally doesn't generate any code which will evaluate the second portion or the second operand or the second expression. Sub expression is not evaluated because this is already true. So regardless of whatever the second expression evaluates to, if you already get a true when you are using the operator, true or false is always going to be true. So a 1 or 0 is going to be 1, or 1 or 1 is going to be 1. And so that's the reason you do not have to, you don't typically, the compilers have been written so that the second part is not evaluated, the first part is already true. All right, so that's just something to bear in mind. Let's keep going. So as I said, okay, and this is the next one, the increment and decrement operators. So I've only given you an example of post increment, of the increment operators. Decrement follows pretty much the same logic. So I have two variables here, jnum and pnum. So jnum is 90, and when I use the post increment operator on jnum and I store it in pnum, pnum actually has the old value. So that's because that's how the post increment operator works. And why is it post increment? Because the increment happens afterwards. So jnum, the original value of jnum gets stored in pnum, so that's 90, and once that has been done, internally jnum gets incremented to 91. So the value that you would see here is post increment pnum is, it's going to be still 90, and jnum, what's jnum going to be? Let's see what's going to be like. So as you can see, post increment pnum is still 90. That's because the old value is returned by the post increment operator. So 90 is stored in pnum. And then after that, jnum is incremented, and that's what we see here. Jnum is 91. So this is how the post increment operator works. Let's look at how now the pre increment works. So we have jnum equal to 900, and this is the pre-increment operator where the operator comes in front of the variable. So what's happening here is now that the increment happens immediately, and jnum gets incremented, and the incremented value gets stored in pnum. So when you output pnum, you're going to get 901. Jnum is also going to be 901. Let's see how that's going to look like. So as you can see, the pre-increment pnum is 901, right? So that's because pnum carries the incremented value. Similarly, jnum has also been incremented, so that's also 901. So those are the values that we expected. All right, let's keep moving on. The next thing I would like to cover is bitwise operators. So bitwise operators, they operate at the bit level. So for instance, take an 8-bit character. So characters are typically stored in 8 bits. When you apply the bitwise operator, you're going to be individually carrying out these logic operations on each bit. So let's say you are going to you got a variable a, and let's say it's a unsigned character, and you have another unsigned character b, and you're going to do a bitwise and on both these variables. What happens is each bit is individually evaluated. Each bit of these two numbers, the corresponding bits, the operation, the logical operations are the bitwise operations are carried out on each of these individual bits at the individual positions, at the corresponding positions. So let's look at an example here. So I have defined a val to be 8. So 8 can be represented, say, I'm just taking the first 16 bits here, assuming that it's going to be a 16-bit length. So when I say 8, this is the pattern that I'm going to have in memory. So the fourth bit is set to a 1. Now what I want to do is I want to actually set the eighth bit also to 1. So basically, this is the pattern, output pattern that I need. So I need zeros, zeros, and then this eighth bit should be 1, and then of course what's already been set. So how do I achieve this? So it's pretty simple. I need to be able to, at this position, OR the 0 with a 1. So if I OR the 0 with a 1, then I'm going to get 1 in this position, in this position. So in order to do that, I should be able to declare some variable which contains a value where it's 1 only in this position and zeros all over. So I need something like this. So this is going to be the value 128. So if you convert this representation in binary to decimal, it's going to be 128. So what I'm going to do now is, because I want this to be the final output, I'm going to OR this pattern with the original input. So when I OR both these together, this one and the 128, as you can see, 0 with 0 is 0, 0 with 0 is 0, 0, 1 and 0 is 1, and once again at the eighth position you'll get 1 and 0 as 1, and so this is the final output that you would get, right? Because you have carried out a bitwise OR. Now how do you do the bitwise OR? So you need to note that it's different from the symbol for the logical OR. The logical OR has two pipes, whereas the bitwise OR has just a single pipe. So when the compiler encounters this sign, it knows it's a bitwise OR, and that it has to carry out the truth operations on each individual set of bits. So that's what happens here. Eval is bitwise ORed with this setter variable in order to get this output. So each individual set of bits is um, evaluated using the bitwise OR operator, and we finally get this output. And what is this output? We can output it as final val. I'm storing that in another unsigned variable. So what's the output that I get? Let's take a look at what the output for this would be. So as you can see, the modified value is 136. So if you try converting it, so this is going to be 8, and at this position we are going to get 128. So 128 plus 8 is 136, and which is what is displayed on the console there when it is converted to a decimal. So that's this sentence executing. All right, so that's all good. Now let's keep going. As I said, there's also the right shift operator and the left shift operator. These are also bitwise operators. So this is the final output pattern that I have got, 136. So I'm going to right shift all the bits by just one position. So when you right shift, every bit moves one position to the right. That's when you right shift. Similarly, if you left shift, every bit is going to move one position to the left. And how many positions it moves depends on this operand. So here I'm actually only right shifting it by one bit. So if I want to right shift it by 2 bits, I would say 2. But in this example, I'm just going to use only 1 bit. So once that happens, so this is going to shift, this one is going to shift to this position. And similarly, this one will shift to this position. So the fourth bit shifts to the third bit, and the fifth bit shifts to the fourth bit, and so on. So this eighth bit will shift to the seventh bit. Now one nifty trick here is that when a right shift by one bit happens, it actually divides the number by 2. It's equivalent to dividing the number by 2. So we know that this is 136. So when we divide 136 by 2, what's the value that we are going to get? We're going to get 68. So that's what we will see here as our final value once it has been right shifted. All right, so let's see that in action. See, the final value is right shifted by 1 bit and we get the value 68. There's one more thing I would like to bring to your notice, and that is that I've used compound assignment here. So this is definitely much more succinct the way you write it, and it's equivalent to, if you expand and write it, it would be equivalent to this. Final val is equal to final val right shifted by 1. So it right shifts by 1 and then it returns that to be stored in the same variable. So the variable gets overwritten. Instead of that, I'm just going to use this compound assignment. This is more neat and easier to comprehend. So as you can see, we have got the value that we desired, 68. With that, I come to the end of this demonstration. So there are other operators too, which you might want to quickly have a look at. I have not covered it as part of the basics of this course. Um, if you have any questions about the other operators, feel free to send me a query and I'll be happy to answer. The other operators are the size of operator, which actually takes, returns the size of maybe the data type or the size of an object on which it is operating. The comma operator is another operator which is used, for instance, within for loops. You use a comma operator. Then you have the member access operator, which I will anyway be covering when I cover classes. Every class has members, and then this is the member access operator. So the member access operator is either a dot if you're using the object to access the members, or it could be the arrow operator. Oops, or it could be the arrow operator. So it's that or the dot. And then you have the conditional operator. This is given just for the sake of completeness. It's a little confusing to write it if you do not know how to use it properly. So I wouldn't really bother too much about the conditional operator, but for the sake of completeness, maybe you could try writing out a few programs to get familiar with it. All right, with that, we come to the end of this video, and I'll see you in the next one.